Here's an equation graphed in a previous lesson. We began with the equation at the top, y is equal to negative 3x plus 4. We made a chart where we wrote down some numbers for x, did the arithmetic to find the corresponding numbers for y. That gave us 4 ordered pairs. We then graphed them. They're marked by the 4 red dots. And of course, it's a linear equation. Our arithmetic was good, so the 4 red dots lined up. We connected them to get the purple line, which is the graph of the equation at the top. Notice that we can examine this line and notice that it crosses the y-axis at 4. That's the y-intercept. Also notice that there's a 4 in this equation. Pick 2 points and we go 3 up and 1 to the left. That gives us a slope of 3 over negative 1 or negative 3. Notice there's a negative 3 in this equation. Well, let's look at another one. Here's another equation graphed in an earlier lesson. Y equals 2/3 x take away 3. We start with the equation, we make the chart, we get 4 ordered pairs, we graph the 4 ordered pairs, and we connect them. Now, let's find the y-intercept here. It's negative 3. And in the equation, we don't have a negative 3, but we have a subtract 3. But remember, subtract 3 is the same as add negative 3, so there is a negative 3 in that equation. Let's look for the slope. We pick 2 points, we go 2 up and 3 to the right. Slope is 2/3. And yes, there's a 2/3 in this equation. And that brings us to something called slope-intercept form. When an equation is solved for y, it is often written y equals mx plus b, where m is the slope and b is the y-intercept. When we looked at the slope formula, we identified that the letter m is often used for slope. Now we know that the letter b is often used to represent the y-intercept. Once again, I don't know why the letters m and b were chosen, but it's worth memorizing that often when you see m as a variable, it'll stand for the slope of a line, and when you see b as a variable, it often stands for the y-intercept of a line. Well, now that we know slope-intercept form, if we're given an equation in slope-intercept form, we should be able to identify the slope and the y-intercept without graphing. This one's pretty straightforward. We do substitution and we realize the slope has to be 3 and the y-intercept has to be 5. This one a little more complicated because of the subtract 1. Remember that subtract 1 is the same as add negative 1. The slope's pretty straightforward, negative 7, and the y-intercept, negative 1. Here's a fraction. Shouldn't create a problem. The slope is clearly negative 3/5, and the y-intercept is negative 4. We didn't show our work, but when we see a subtract 4 in slope-intercept form, remember that means the intercept is negative 4. Decimals, again, shouldn't be a problem. Slope 0.4, y-intercept 1.5. And here's one. It says the opposite of x plus 42. Well, remember, when there's no coefficient, we can put a 1. And since there's a negative symbol there, that makes the slope negative 1. And of course, the y-intercept is 42. Here's one that just has an x take away 2. So the coefficient of x is 1, even though it's not written, because 1 times x is x. So the slope is 1, and the y-intercept is negative 2. And here's one doesn't seem to have a b, but we can rewrite that as y equals 3x plus 0. And that's because of the additive identity that anything plus 0 is itself. So clearly, now that we've rewritten it, the slope is 3 and the y-intercept is 0. And here's one that you might remember is the equation for a horizontal line. We can rewrite this one as y equals 0 times x take away 2. And now we realize the slope is 0 and the y-intercept is negative 2. And of course, this is a horizontal line. Here's an equation for a vertical line, and equations for vertical lines cannot be written in slope-intercept form. Now, we can use an equation in slope-intercept form to get a quick graph. Just as we were able to get quick graphs using intercepts, once an equation is in slope-intercept form, it's generally fairly quick to get a graph. We start by looking at the y-intercept, in this case the 4, and we graph it at y equals 4. And then from that point, we look at the slope, which is -3, and we go 3 up and 1 to the left. We could also go 3 down and 1 to the right, but either way, these points will line up, we connect them, and there's our quick graph using slope-intercept form. And then we remove our work so that we can see the graph and the original equation with all of our scratch work alongside. Let's try another example. We identify the intercept. Remember that a subtract 1 means the intercept is -1. And from that point, and this is important, don't start at the origin, start at the intercept, go 3 up, 5 to the right, place another point, connect the 2 points, and there's your graph. We remove our scratch work, and now we have the graph of the equation y equals 3/5 x take away 1. To summarize, an equation written in this form, y equals mx plus b, is in slope-intercept form, where m is the slope and b is the y-intercept. To graph an equation that is written in slope-intercept form, first graph the y-intercept, then starting at the y-intercept, use the slope to graph another point. Finally, connect the 2 points to form a line.